Everyone,
Yeah.
Start?
Yeah, please.
Yes. Hi everyone, my name is Ahmad and along with me I have Abdullah, and today we are here to present our project Dermopsy. Skin cancer and fungal infections are one of the most diagnosed cases around the world, with 30 million plus diagnosed cases, out of which 1 million plus deaths occur. The current methods require invasive procedures like biopsies and require chemical staining. Research has shown that the survival rate can increase from 35% to 99% if the cancer is detected early. If we talk about the process of traditional staining for diagnosis, what happens is that the doctor performs biopsy, he cuts out a tissue sample, puts it on slides, passes it through chemicals. Those chemicals give the tissue a specific color which enhances the nuclear features of the tissue, and then the doctors can use that stained tissue to perform microscopic examinations and diagnose cancer. The problem with these conventional methods are that you need to perform invasive procedures. Biopsies, which leave scars on your body, is a painful procedure and is costly. You need to add chemical dyes to the samples for them to enhance nuclear features. This is a time-taking and a costly process, and these chemicals are harmful for the aquatic environment as well. Staining one slide takes $3.7 to $8 depending on the size of the tissue, and the time is usually 2 to 3 days. And for the fungi, the doctors have to identify the region manually where the fungal infection is present. So our solution has two modules. The first module is virtual RCM staining, where we perform the staining of the skin tissue virtually. We use a special microscope which does not require biopsy. It gives us an image, we pass it through our generative AI model, and it gives us a stained image. The second module is the detection of fungal infection using deep learning frameworks. We input a stained slide, pass it through neural network, and it detects the fungal infections. So Dermopsy is basically a platform for histopathologists to perform rapid non-invasive diagnosis using generative AI and deep learning for staining and segmentation purposes. Doctors can manage all the data of the patients on a cloud-based web application. Starting off with the first module, virtual RCM staining, what happens is that the doctor puts that special microscope, reflectance confocal microscope, on the skin. It gives us a high definition image. We pre-process it, pass it through our generative AI model, and that image is then stained by the model, and that image can be used by the doctors to diagnose if it's cancerous or not. The dataset for this was provided to us by Skin Non-Invasive Diagnostics Innovation in Skin, which is a team of dermatopathologists in USA who work on non-invasive procedures. They had 17 different cases, and each region was represented by Viva Block and Viva Stack images. Viva Block images are the ones that provide high detail information of the cellular structure and abnormalities, and Viva Stack images give us image stacks at different depths of the skin. The model we used for staining purposes was a dual contrastive learning GAN which had 11.37 million parameters and had 2 pairs of generator and encoders. This is the reason we went for this model, because it helps the model learn translation from both the stained to unstained to stained domain and stained to unstained domain, which makes the model really robust. These are the outputs for our GAN model. FID was 0.31 and KID was 345. This is the input image after pre-processing and then passing through the model. As you can see, the nuclear features are enhanced. Purple regions represent the nuclei and the pink regions represent the cytoplasm. We also performed qualitative evaluations of our results. We had a board of 3 certified dermatopathologists who basically evaluated our results on different criteria like color, resolution, sharpness, contrast, and etc. And all of those scores were above 80%, which ensures the quality of our product as well. Moving on to the second module, the PS slide analysis. What happens is you use a traditional microscope, we get an image, we stain that, pass it through a neural network, and then perform segmentation. Take out one of the layer of this segmentation mask, because that is the only layer where fungal infection can be present, and then we predict where the fungal infection is present using image processing. The dataset for this was provided to us by Skin again with 32 tissue samples, 17 of them male and 15 female. This seems like a small number for a dataset, but these images are very high in resolution, ranging from 20 to 25,000 pixels in each dimension. So we performed patching on this, which increased our dataset size to approximately 20,000 images. The model we used for this purpose was a segformer, which is a transformer-based model. The reason we went for this model was because of its simplified decoder and its self-attention mechanism. Segmentation workflows goes something like this. We give the stained image, we perform segmentation, post-process it using image processing, and these are the results for a segmentation. 85% mean IU, 82.3% dye score, and 89.8% mean accuracy. For fungi detection, after extracting one of the layers, we perform image processing techniques like RGB histogram, and as you can see, these yellow regions represent where the fungal infection was present. If you talk about the competitors, there's other products who are working on this domain, but only Dermopsy is the one who's totally focused on non-invasiveness, digital staining for AI, using AI and deep learning for digital staining, and completely non-invasive.
Now, if we talk about the staining process, there are approximately 3 million slides that are stained with H&E stain daily. So this makes us think about the total market size. Well, the cost to stain each slide ranges from $3.75 to $8 depending upon the size of the slide. So the total market size globally is expected to reach $21.3 billion by the year 2032 with an annual growth rate of 7.21%. And 60% of this is the cost of the H&E kits and consumables used. If we talk about the local market size in Pakistan, there are only 18 histopathology labs and 338 trained histopathologists against the 180,000 new cancer cases that emerge every year. Also, the market size is $150 million in Pakistan, which is growing at an annual rate of 5.1%. So our business model, in our business model, we have subscription-based plans in which the individual plan can be used by our histopathologists and the enterprise plan can be used by laboratories that are working in this domain. If we talk about our advisors play a pivotal role in shaping and refining our product. So Dr. Usman Akram helps us with his technical expertise. Dr. Babar Rao provides invaluable insights in the medical field, and Ozal Zisha helps with the marketing campaign. Similar to our advisors, our collaborators are also working in diverse domains. We have collaborated with RiceTech and Biomisa from Pakistan and APPNA and Needy Skin from USA, which help us in the clinical, industrial and biomedical research domain as well. Over the last year, Dermopsy has achieved significant recognition both nationally and internationally. Notably, it was ranked among the top 100 innovations at Prototypes for Humanity 2024 out of 2,700 submissions from 100 plus countries. So this shows the innovative nature of our solution, which is further backed with copyright application of our algorithm and application design along with journal research article. As we conclude, I'd like to highlight the broader impact of our solution. Beyond its technical and medical innovation, our work is designed in a way to advance the way in which healthcare is delivered. So our solution not only eliminates the water and chemical usage, but it also reduces the staining cost because we perform the staining virtually. It also eliminates the need for invasive biopsies and allows the histopathologist to perform quicker diagnosis, which in result increase the survival rate from 35 to 99%. This is all from our slides. Now I'd like to show you a little demo.
Okay, so as you can see, this is the home page. The doctor basically starts off with the home page. He goes to the virtual RSIM staining segmentation segment part. He selects the image that he has to virtually stain. He uploads it. He can look into it using a microscope, and he can also process it using the GAN model. After processing, this takes 30 to 40 seconds, but it's sped up. The doctor can use this image, download it, zoom in, and identify the regions where the cancer could potentially be present. Moving on to the other module, the staining part for fungi segmentation. The doctor selects the stained slide, uploads it, processes it. This takes approximately 1.5 minutes. And it generates the masked image and the fungi segmented image as well with the legend of this segmentation mask. Doctor can download these images as well, again zoom into it and perform his diagnosis however he wants to. These images are very huge in size, again 20,000 to 25,000 pixels. So these do take some time in downloading depending on your internet connection. Once it's downloaded, again for the fungi segmented, this is the image that is being downloaded right now. After it's downloaded, the doctor can open it, and as you can see, if we zoom into the region where fungal infection is present, this yellow region, everything this represents where the fungal infection was present, and this was done with 86.8% precision. That's it from our side. Thank you so much.
Thank you.